So in this video, we will discuss, does the rudder turn the ship? So, and immediately to answer this question, the rudder does not turn the ship. A lot of officers and also masters are still believing that the rudder will turn the ship. The video will illustrate and describe that the rudder does not turn the ship and it's only initiator for the turn. It will demonstrate what force are required to turn the ship. So how does the ship turn then? And if not the rudder, then what is that turns the ship? And that we will discuss in this video. So in this first illustration, we will see that the rudder is placed to starboard side, so which means the helmsman places the rudder from the midship to the starboard side, somewhere to the starboard side. So this causes that there is a lifting force acting towards the opposite side, and this is a rudder force. The rudder force is always in opposite side of the rudder, what the rudder angle we will do. So, and this is regardless if it is to starboard or port side. So, which means this is the same. If I'm now placing my rudder to the port side, the rudder force is acting the opposite to the starboard side. So the direction of the lift force, this lift force here, or this one, depends on the direction of the rudder, is here in this case to the port side. The rudder force is directed along with the transverse direction to the ship. In other words, the force will cause the ship to attain a sway velocity towards the port side. The sway velocity is acting here also on the transverse axis. So, and the rudder force is nothing else but the sway force. It is because of this a ship will sway slightly to port side when the rudder is turned over to hard starboard. So what else? The rudder force has another effect on the ship. It creates a moment about the center of gravity of the ship. The center of gravity of the ship is forward of the rudder, you can see, and given the direction of the rudder force, the moment it will create. So which will be here a moment which will be created because the rudder is to starboard side to the starboard side. So which means here clockwise. And if it is to the other side here, then the moment will be created to the port side. So the drift angle due to rudder moment. When the rudder moment acts about the ship's center of gravity, it slightly changes the ship's orientation by giving it a drift angle. This is the drift angle here. So which means this is actually the ship's velocity, where the ship was originally on this course. And now if I'm put my rudder to the starboard side, I will create a drift angle here. This moment is not large enough to turn the ship to the required heading angle, but all a designer has now to do is to make sure that the rudder moment is enough to introduce a slight drift angle into the ship's movement, what will be represented here. The ship with this drift angle is now moving along the initial direction, but it's no longer poor surge anymore that we can see. We have here the sway velocity and we have the surge velocity. Before we had pure surge velocity, but this is no longer the case. So which means here the connection between the sway velocity and the, if it intersects with ship's velocity, this is a surge velocity. We will see that you can make components of the ship velocity along the surge longitudinal direction and sway the transverse direction. That is the surge in the longitudinally, sway in the transverse direction. Thus, it's evident that by introducing a drift angle, the rudder has introduced a small surge velocity of the ship. So we see this here. That is the original position. Now the ship will be turned to the starboard side. I have here my rudder force acting, and this is actually my ship's velocity. So now, this is now the drift angle. The drift angle is the angle which will be caused by the rudder moment and also here the ship's velocity. And this drift angle actually introduces a small surge velocity to the ship. So therefore, the hydrostatic moments due to the sway velocity will now change. The prime focus should be on the sway component, because the sway velocity component is what changes the hydrodynamics around the ship's hull to cause it to turn. So we are facing now, and we are, let's say, focusing on the effect of the sway velocity and how it turns the ship. So which means We always set the sway velocities in the transverse direction along the transverse axis, and it's in opposite of the rudder angle, which will be laid. So here to the port side. So with a sway velocity towards the port side, the whole sways to port side and not to the starboard side, slightly we said. When it does not so, it exerted a force in the water particles that are in its port side. So all the water particles which are here will be now exerting a force. The water particles in turn exert an opposite force on the ships due to the inherent inertia of the water particles. And this direction of the inertia force is always in the opposite of the sway. That means here is the sway velocity, and the initial inertia forces are always in opposite to the sway direction. That means they're acting here to starboard side, and the sway velocity acts to port side. So the ship will experience an inertia force on its hull in the starboard direction. Now this force can be categorized in two. One part is acting at the stern here, and the other part is acting at the forward. So, and if we are following now this illustration, and we can visualize that the inertia force at the stern will create an anti-clockwise. That means here an anti-clockwise path towards the port side, and forward it is a clockwise. So which means moment due to both forces are clockwise here. This now, the hull is now designed such that the sway inertia forces at the bow, there are more inertia forces at the bow than actually at the stern. Therefore, the resultant moment is towards the starboard side. So which means the resultant forces from the inertia force at the stern and the inertia force at the bow. We have, let's say here 1, 2, 3, 4, 5, and here only 4. That means the resultant moment is to the starboard side. So what is important to know here is that when the hull exerts forces on the water around it during its sway velocity to the port, the inertia forces exerted by the water on the hull tries to achieve an equilibrium, which means the magnitude of the inertia forces is in the order of the ship's displacement. It is that large a force, so when the resultant hydrodynamic forces or moments act on the ship, its magnitude is in order of the ship's displacement. The moment, unlike the moment caused by a rudder force alone, is sufficient enough to turn the ship. But we can see this also, the hydrodynamic moments would have come to play had the ship not attained the drift angle or sway velocity component, which was mainly due to the action of the rudder. This is enough to justify that the rudder does not turn the ship. It's only initiated a drift angle and the ship, which results in a hydrodynamic moment, which is actually the driving force behind the turning action. So which means if we do not have this drift angle, and we would not have this rudder force acting to the port side, always to the opposite to the rudder angle, then the ship would not turn. So to see this, we can see this here. Here we have the drift angle. Now the ship is turning due to this drift angle. The hydrodynamic moment in this same direction of the rudder moment, that means both trying to turn the ship to starboard. The rudder angle keeps the rudder moment intact, which in turn keeps the hydrodynamic moments intact. Once the rudder is again brought back to midship, first the rudder force vanishes, which results in the diminishing of the rudder moment. So it is only after that the drift angle is reduced to 0 and the hydrodynamic moment becomes 0, therefore thwarting the turning action. So let us see for this a small video which can present this, what will happen if the rudder forces are coming. So to demonstrate that the rudder force and also the drift angle will be disappeared and go back to 0 as soon as I put my rudder midship, we can demonstrate this just on a small example. So I will put my rudder on the starboard. And then we can see that is actually the way the ship will go, and that is my velocity and what I will expect in 6 minutes. So which means now I'm turning my ship. You can see that I for sure here, this will be now the drift angle, what we will see. Now, if I will place my rudder midships, and continue with my, and then we see here that the rudder force and also here the drift angle is no longer there. We can see this also that we have no opposite rudder force because here my bow and my stern speed are nearly the same, or there's no different. Therefore, the whole rudder force acting. So now we have seen what will happen. So which means it is due to this indirect linking of the rudder to the turning action that ships are sludging when it comes to maneuvering with rudder action. So thanks for watching, and I hope that you now know that the rudder is not turning the ship and that there are other forces necessary to turn the ship, and the rudder is only an initiator.